Hello students, today we'll cover solution part 1 unit 2 class 12 science chemistry. Okay, as the name of the topic suggests, here we are going to talk about the solution. Now the definition of solution is it is a homogeneous mixture of its component. In solution we have two components, one is solute, another is solvent. The definition of solute is this is the one which present in the solution in lesser amount, and the number of solute in the solution may be more than one. Then the definition of solvent goes as it is the component of solution that is present in larger quantity. Okay, it will be present in more amount than that of the solute, and this is referred as your solvent. The solvent in the solution determine the physical state of the solution. That means if your solvent is liquid, the physical state of the solution will be liquid. If it is gas, then the physical state of the solution will be gas. So physical state of solvent is same and it determines the physical state of the solution. And solvent in the solution will be only one in number. One example of solution we can take, if we are talking about the lemonade, then to prepare the lemonade we need water, salt, sugar, lemon. Water is in major quantity, so water is your solvent, and sugar, salt, lemon juice, these are in small quantity, so these all are your solute. So in this solution you can see you are having only one solvent and three solutes. Next, here is the table that gives us 9 type of solution. Now how we get this 9 type of solution? By mix and match of different physical state of solute and solvent, we are getting this 9 type. So whenever we talk about the gaseous solution, your solvent must be gas, okay, and the solute may be gas, liquid or solid. Same way when we talk about the liquid solution, the solvent is common, liquid, and the solute may be gas, liquid or solid. Same as solid solutions, here the solvent is solid and solutes are gas, liquid and solid. One example is given. For example, if your solute and solvent both are gas, the common example is air. In air we are having carbon dioxide gas, oxygen gas, nitrogen gas, but which one is the solvent? Nitrogen gas is 78%, so it can act as a solvent, others are mixed there. So it is air is an example of your gaseous solution where both solute and solvent is gas. Another example where solute is liquid and solvent is gas is chloroform mixed with nitrogen. So from this table you can see different example of different solute and solvent combination. Next we'll go for the solubility. We'll understand what is the solubility. So solubility is the physical property of a solution. This is defined as the measure of maximum amount of the solute that can be dissolved in a quantified amount of solvent. So if you take a particular amount of solvent, how much solute you have dissolved there, that defines the solubility of this solution. The property of solution depends upon some factors. Now the factors are the nature of the solute and solvent and the interaction between them. So if the solute and solvent between them, the interaction is very strong, the solubility of the solution will be higher. So stronger is the interaction between solute and solvent, stronger will be the solubility, or more stable the solution will be. Next, molecular size of the solute. If your solute is larger or bigger in size, the solubility is lesser. If you are trying to dissolve a big crystal of salt in the water, you will see it will take more time than if you are using the powder salt. So larger the size of the solute, lesser the solubility, and smaller the size, solubility increases. Next, polarity. Polarity here, like dissolve like. This formula goes. That means if you are dissolving polar solute, it will dissolve readily in the polar solvent. Similarly, if you are trying to dissolve non-polar solute, then you have to choose the non-polar solvent. So if the polarities of solute and solvent is same, solubility is higher. Then temperature and pressure. With the increase in temperature and pressure, solubility of solid in the solvent increases. Okay, so these are some factors that determine the solubility. Next, some phenomenon we'll study. One is dissolution, another one is crystallization. So what is dissolution? The phenomenon of increase in the concentration of solution due to dissolving of a solid solute. Do remember, solid solute, the solvent is known as dissolution. So if you are taking some liquid and there you are trying to dissolve some solid solute there to make a solution, then the process will be termed as dissolution. Example, dissolution of salt or sugar in water. Next is crystallization. The phenomenon of collision of solute particles in a solution resulting in the separation of the solute particle from solution is known as crystallization. So if you are taking a saturated solution means in a particular amount of solvent you have added the solute to the limit. Okay, more than that much amount of solute you cannot add there. So if you have taken such a saturated solution, then what happens? The solute particles collide with each other, because in water they are in motion, so they will collide with each other, and with the collision they result in the separation. Okay, they will separate out, and this process is known as crystallization. You have done the crystallization of copper sulfate, so that is an example of this crystallization. Crystal of copper sulfate obtained by the crystallization of copper sulfate solution. Okay. Next we will see the solubility of a solid in a liquid. A phase when number of solute particle goes into the solution is equal to the solute particle separating out of the solution. This is known as equilibrium. So what does it mean? It means that at equilibrium state, the amount of dissolution or the rate of dissolution is equal to the rate of crystallization. So when both the rate are equal, then what happens? The equilibrium established in the solution. Now based on this, we got a principle termed as Chatliers Principle. So Chatliers Principle states that in a saturated solution, if dissolution process is endothermic means what? Heat will be absorbed from the surrounding to the solution. So if you have taken a saturated solution and you are dissolving some solid solute into the solvent, the process, if it is endothermic, then solubility will increase with rise in temperature. But if it is exothermic, then with the rise in temperature, what will happen? The solubility will decrease. So that is the Chatliers Principle. Another factor is pressure does not have a crucial effect on solubility of solid in liquid, because they remain unaffected to pressure due to the high incompressibility of the solid and the liquid. So if you are trying to dissolve solid solute in liquid, then pressure will not affect. Earlier we have studied that solubility depends on temperature and pressure. So here, as per Chatliers Principle, we understood that how temperature is performing their role. Okay, but pressure in dissolving solid into solvent do not have any effect, because solid are incompressible. So if you are applying pressure on solid, the pressure will not work. So solubility of solution made by dissolving solid in solvent will not be affected with the pressure. So this is your Chatliers Principle. The first one is your Chatliers Principle, and second is the point to remember. Next, solubility of gas in liquid is highly affected by temperature and pressure. So unlike the solubility of solid in liquid, solubility of gas in liquid is affected by both temperature and pressure. Let's see how it get affected. Now, increase in temperature reduces the solubility of gases in liquid because on dissolving gas molecule in liquid, the process of dissolution is similar to condensation, leading to evolution of heat. Therefore, dissolution is an exothermic process due to which solubility decreases with increase in temperature. So, in case of a solution that are being prepared by dissolving gas into the solvent, if you are increasing the temperature, instead of increasing the solubility, solubility will decrease. Okay, so this is the reverse case. So if you are dissolving solid in liquid solvent, then with increase in temperature, solubility increases. But if you are dissolving gaseous solute in liquid solvent, then with increase in temperature, solubility will decrease. So you have to remember this. Next, increase in pressure by compressing the gas to a smaller volume increase the number of gaseous particle per unit volume over the solution and also the rate at which the gaseous particle are striking on the surface of the solution to enter it, leading to the increase in the solubility of the gas. So if you are applying pressure while preparing a gaseous liquid solution by dissolving gas in it, then high pressure if you apply, the solubility will be more. But earlier we have studied that if the solution is prepared with solid solute in liquid solvent, then pressure do not affect. So both the process are contrast to each other. Be very clear about it and remember it. So that's all for today. Thank you.